Okay, welcome students. Let's do chapter 4, 4.2 translations of sine and cosine graphs. So recall the graph of y equals f of x minus d is a horizontal translation, okay, and it moves over d units, okay, horizontally. The graph of c plus f of x, I would normally do f of x plus c, but I don't know why they did that reverse, but this is a vertical translation. So horizontal is left and right, right? Horizontal left and right, and vertical is up and down, okay? Now a horizontal translation, when we move things horizontally, with regard to circular functions, that is called a phase shift. Okay, it's just a horizontal translation. We're just pushing the graph over in right or left, and we're translating all of the points all at once. Okay. Two ways to graph circular functions. Two ways of graphing circular functions of the form y equals c plus a sine b x minus d. Now, a and b are the same a and b that we were working with in the previous section. C is going to be that up and down shift, and D is going to be that left and right shift. Okay, so y equals C plus A sine BX minus D, or y equals C plus A cosine B times X minus D are, one, find an interval of 1 period by setting the argument between 0 and 2 pi. Okay, so find one interval, and then 2, graph the basic functions, and then use translations to graph the desired function. Okay, so what we're going to do is we're going to find what A, B, C, and D are, and then interpret how that's going to displace all the points in the graph. Okay, so we're going to start again with A and B. So in this case, A is equal to -2. B, if we look at the cosine function here, B is the number in front of the X value factored out. And that's just 1. There is no number, but there's an imaginary 1 right here. Okay, factored out of the parentheses X minus pi over 3. Okay, C would be something that's added at the very end or the very beginning to the function. There isn't anything, so that's 0. So there's no vertical shift up and down. There's none of that. No up and down shift. But there is going to be something called a phase shift, and we're going to shift this pi over 3 units, and it's going to be a positive. The sign is always opposite. Okay, if it's X minus pi over 3, then this is pi over 3 units to the right. So it's always opposite. If this was a plus, then it would be pi over 2 units to the left in the negative direction. But this is pi over 3 units to the positive direction. Okay. Okay, and so D is pi over 3. So what we're going to do here is we're going to see the net effect of all of these things. Well, again, we don't have to worry about C because C is 0, so there is no shift up or down. There is a shift right, pi over 3 units. B is 1, so there really is no, how can I say this? There really is no period. It doesn't change, the period doesn't change. Okay, it's still going to be 2 pi over B, but B is 1. So it's just 2 pi. Okay, so the period doesn't change. Okay, so that's nice. So if we did 2 pi over 4, that would mean that every pi over 2 units are my divisions. Okay. And but the big thing here is that there is a vertical stretch of -2. That's going to stretch and flip. So we're getting a stretch and a flip. Okay, so we're getting a flip and a stretch of 2, okay, of multiple 2. And at the same time, we are getting that movement or that translation or that move right by pi over 3 units. Okay, so we're gonna flip, we're gonna stretch vertically. Okay, vertical stretch. And we're gonna move everything pi over 3 units. Okay, so if we had originally pi over 2 unit divisions, then we would start at 0, then go to pi over 2, then go to pi, then go to 3 pi over 2, and then go to 2 pi, right? So that would be the divisions that we use to mark those key points, those reference points. But we're going to have to move everything pi over 3 units. So this 0 point on my cosine function is going to actually be moved to pi over 3. The pi over 2, if I add pi over 3 to that, that becomes pi over 6, okay? If I add pi plus pi over 3, I get 4 pi over 3. So this gets moved to 4 pi over 3. Add a pi over 3 to a pi, which is 3 pi over 3. 3 pi over 2 plus pi over 3. You have to add pi over 3 to everything. Okay, that is going to be, get a common denominator of 6. Okay, 3 times 3 is 9, plus 2 is 11. So this is 11 pi over 6. Okay, so that's going to get moved to 11 pi over 6. And then 2 pi is going to be, well, it's just going to be back to pi over 3, which is, I mean, it's 2 pi, which is 6 pi over 3 plus another pi over 3. That's 7 pi over 3. Okay, so that's 7 pi over 3. So this is how all of the new values are going to be. These are going to be the new values for my reference points. Okay, so I get these new values. So let's go ahead and graph this and see what's happening. So I'm going to go by, what do I want to do? I'm just going to go by pi over 3 here. And then we're going to see what the net effect is. Okay, normally for the cosine, we would start here at 2. Okay, on the top, but we're flipping, right? Because we would normally start at 1, but then we're stretching. We're doing a vertical stretch of 2, and then we're going to flip that upside down. Okay, and so we're actually going to start at -2, but we're not going to start at 0. We're going to, everything again is going to get pushed over pi over 3 units. So if this say is pi over 6, then this is pi over 3. Okay, and then the next one would be, what would the next one be? The next one would be 1 pi over 6, 2 pi over 6, 3 pi over 6. That would be pi over 2. And the next one would be add another pi over 6. That would be 4 pi over 3. I think. Nope. Is that right? No. It'd be 2 pi over 3. 2 pi over 3. And then we would get, think about this for a second. 2 pi over 3, which is 4 pi over 6. And then, oh yeah, 5 pi over 6. So 5 pi over 6, that would be my next reference point. Okay, so 5 pi over 6, okay, would be the next reference point there. Okay, and so I'm just going up by pi over 6's are these values here. And then from 5 pi over 6, we're going to be at pi. I'm just going to go around the unit circle with the pi over 6's. Okay, just to space things out pretty evenly. And then at the next pi over 6 is going to be 7 pi over 6. The next pi over 6 is going to be 8 pi over 6, which is 4 pi over 3. And I believe that was our next point. Yep. And that's going to be at +2. So it's looking like it's going to be like this. And then it's going to go like that. Okay. And I'm going to have to extend this out pretty far. Okay, because we're basically halfway there. And now we're going to go, the next pi/6 is going to be 5. No, it's going to be 9pi/6, which is 3pi/2. And then 10pi/6, which is 5pi/3. And then 11pi/6. You can see every 3 pi/6s, I'm getting another reference point. Okay, and so if I went 1, 2, 3 again, okay, 11pi/6, 12pi/6 is 2 pi. And then this is going to be 2 pi plus pi/6, which is 12, 13 pi/6. And then this next one is going to be 7 pi, 14 pi/6 or 7 pi/3, which is going to be our last reference point. So I'll put my reference points in black here. And this is just one cycle. The whole thing is a period of 2 pi. But we did increments, oops, I'm hard time drawing. We did increments of pi/6 just so we get a real accurate graph and see what's happening. And we can see that, look, everything got shifted pi/3 units over, right? The original graph would have been at 2 pi here where it would end, but it was shifted over, okay? So everything got shifted over. Okay, this would be where the original ones would be, our original reference points, and everything got shifted over. Okay, and pi would be my other reference point here. That got shifted over. Okay, 3pi/2 would have been my original reference point, and that got shifted over. And then 2 pi would be my other reference point in my original period of 2 pi, but then that got shifted over. I'll put the arrow down where the point is. Okay, that got shifted over. So we see that each of these points actually got shifted over. Okay, that there. That one should not be a black one here. This should be, okay, I shouldn't have started there. I should start here at pi/3. Because this original value there was shifted over. Okay, and so we get this guy. Okay, so that's how we do that one. Okay, next example. Okay, this one is very similar to one we did in the previous section. However, it has a C, no D in this case, but it does have a C, which means it's going to be, everything is just going to be shifted down 2 units. Okay. Sign value, okay, A is equal to 3, B is equal to 2, so the period is going to be reduced. Okay, so the C value is -2 and the D is 0, so no phase shift. No phase shift. Okay, but there is a shift vertically down. Everything is going to go down too. Okay, so if we were to kind of write this out, we would say that the amplitude is 3. The period is 2 pi/2, which is pi. So I'm going to use divisions of pi/4, okay, for my divisions. Okay. Okay, no phase shift, which is kind of nice, but everything is going to be translated or moved down 2 units. Moved down 2 units. Okay, so let's see what this one looks like here. So this one, not as complicated as the one before. We have 4 divisions. Okay, and each of them are going to be pi/4. So pi/4 plus pi/4 is pi/2, plus pi/4 is 3 pi/4, plus pi/4 is 4 pi/4 pi. Okay, so that's cool. The amplitude is going to be 3. Okay, so the amplitude, and this is the sine value. So we would normally start at 0, and then we would go up to 3, right? And then down to 0, and then down 3, and then back at 0. However, the last thing that we need to take into account now is that everything was translated down to. Okay, all 5 of those points have to be moved, and I'll put them in black so we can see them. All 5 of these points have to be moved down 2. So I'm going to shift this one down 2. I'm going to shift the next point down 2. I'm going to shift this point down 2. Okay, so he's about there. Okay, and then this point, well, that goes down to 5, -5. This goes down 2, and then this one goes down 2. So we can see that our midline became -2. Okay, which should make sense. Okay, this D value is going to give us our C value is going to give us our midline. Okay, so y equals -2. Okay, or y equals C is our midline. Okay, so this is y equals -2. That is our midline there. Okay, this one says to graph this over 2 periods. So we're going to have a pretty long graph here. Okay, so let's see what's happening with this guy. Now, the problem with this here is that it's not in the right form. Okay, we can see that in order to get b, and this was a sine function, right? Yes. In order to get b, we have to have it factored out. Okay, so here b is factored out in front of x minus d. Okay, so I'll highlight that. Okay, b has to be factored out. So we're going to factor out that 3. Okay, so I'm going to rewrite this, not in highlighter. So y is equal to 4 minus 2 sine of 3 times x minus, and now if I factor out a 3, okay, in order to retain the fact that that would be pi, okay, I'd end up with a 3 in the denominator. Okay, because if I were to distribute this, I would get 3x minus 3 pi over 3, which is pi. Okay, if I were to distribute it, so when I factor it out, I have to put a 3 in the denominator for the term that has pi. Okay, so now, now we know what A, B, C, and D are. So A is equal to -2, B is equal to 3, C is equal to 4, and D is equal to pi over 3. So another phase shift of pi over 3. So interesting. Okay, so we've done the -2 before. That was with the first one here. So that -2 is a flip and a stretch, vertical stretch. The amplitude is 2, but there's a flip, okay, because it's -2. Amplitude is 2, but there's a flip, okay. B tells me what the period is. The period is 2 pi over 3. Okay, so that's the period. The one cycle is going to be 2 pi over 3. So 2 cycles is going to be 4 pi over 3. However, what are my divisions going to be? What do I want my 4 divisions to be? Well, if I divide this period by 4, which is the same as multiplying by 1/4, I will get pi over 6. So my divisions are going to be pi over 6. But instead of 4 of them, I want 8 of them this time. Okay, but I want them to start at the phase shift pi over 3. I want them to start at pi over 3. Okay, so very similar to what we did before, having divisions of pi over 6. Okay, so let's kind of put all the pieces together here. And then the C, keep in mind the C is going to move everything up 4 units. Okay, this goes up 4 units for the C. So up 4 units. Okay, so let me give myself a little room. I'm going to put the graph over here. Okay, and again, I'm going to say, well, this is pi over 6. This is pi over 3. This is pi over 2. This is, I mess up on the next one. This is 4 pi over 3. Yeah, 4 pi over 3. This is 5 pi over 6. This is pi. This is 7 pi over 6. This is 4 pi. Nope, sorry. This was 2 pi over 3. See, I always screw up on that one. This is 4 pi over 3. This is 8, 9. This is 3 pi over 2. And then we want 10. Do we already have 8 here? This is 1, 2, 3, 4, 5, 6, 7. We have 7. So we just need one more. Okay, 3 pi over 2 plus another pi over 6 is going to be 9, 10. So that's 5 pi over 3. Okay, if we put one more, that would be 11 pi over 6 and so forth. Okay, we could do one more. We don't need to because we're going to get 2 cycles anyway. But again, our starting value is going to be at this pi over 3 because we would have shifted everything over pi over 3 units. Okay, so what do we want to do here? We kind of took care of the phase shift. Okay, now the period is 2 pi over 3, right? So 2 pi over 3, that's not that big of a period. Okay, it's basically 1, 2, 3, 4 divisions here. Each pi over 6 is going to be a point, a reference point. So that's kind of cool that each one is a reference point. So every division here is going to be a reference point. Nice. Okay, so each pi over 6, each move to the next value is going to be a reference point. Cool, that helps a lot. Okay, now we're going to stretch this thing. The amplitude is -2. Okay, so let's deal with the amplitude first. So the amplitude, if I go up 2 and then down 2, okay, at pi over 3, if it's a sine value, I would have started at 0, right? I would have started 0 for sine. And for the next reference point, I would have gone up 2 because it's a stretch of 2. However, it's -2, so it actually forces me to go down to -2. Okay, okay. Okay, the next one I would go to 0, then I would go to +2, and then I would go to -2. The 7 pi over 6, I will go to, or sorry, go back to 0 at pi, then -2, 0, +2, back to 0. Okay. However, we have not taken into account, we've drawn basically where the points should be, but we do have to take into account that we have to shift all of these points up 4 units. So the midline was at y equals 0, which is the x-axis. However, we're going to have to translate all of these points up 4 units. 3, 4, 5, 6. And so 0 now goes to 4. Oops, that's 3. Okay, 0 goes up to 4. Boom. -2 goes up to +2 because we're having to shift all of these values up 2. 0 goes up to 4. +2 now goes up all the way to 6. Okay. 0 goes up to 2. Okay, so we can kind of see what's happening with this already. That's nice, nice. Okay, -2 goes up to 2. 0 goes up to 4. 2 goes up to 6. and 0 goes up to 2. So we get another cycle. And so we can see that there's, 2 cycles there, 2 cycles of the graph. And that's how we graph, these as they get more and more complicated. Okay, so that's about where we stop with dealing with sines and cosines. The next section we'll deal with tangents and cotangents. Okay, a little different of a take on those guys. Okay, I'll see you in the next video.